We solve the following problem. State the distributive laws for sets. Now, the distributive laws are as follows. Let A, B, and C be three sets. The first law says that A intersection B union C is equal to A intersection B union A intersection C. The second law is A union B intersection C is A union B intersection A union C. So the first law deals with basically intersection outside, union inside. Second law, union outside, intersection inside. So these are the two distributive laws. A intersection B union C is A intersection B. That means A meets B and then A intersection C. In between there is a union. Similarly, A union B intersection B is A meets B, A union B. There is an intersection there and then A union C. This is the first problem. Second, in a class of 60 students, 35 joined the reading club, 40 have joined the poetry club. Also, each student has joined at least one of these two clubs. How many students have joined both the clubs? How many students have joined only one of the two clubs? So we start it this way. Let A be set of students who join reading club. B be set of students who join poetry club. Now we draw the diagram in which there is a reading club, there is a poetry club. Now these are students who are there both. So let X be the students. Now we are nowhere given the students who are there in the reading as well as the poetry club. So since we are not given anywhere the students who have joined in the reading as well as the poetry club. See, we have given 60 students is the total. 35 are for reading, 40 are for poetry, but there is no mention about those who have joined both. So therefore we take it as X. Now reading there are 35. So overall this circle is made up of 35. This entire full circle of reading is made up of 35. So inside this part it will be 35 minus X. Similarly, the full poetry circle is 40. So inside this part it will be 40 minus X. Therefore, now if I add this total, that means 35 minus X plus 40 minus X, I should get the total as 60 because students have taken either reading or students have either taken poetry. So therefore this is the thing. So therefore I get 35 plus 40 minus X, X goes and you get it as 60. 75 minus X is equal to 60. 75 is equal to 60 plus X. 75 minus 60 is equal to X. Therefore 15 is equal to X. Now this 15 is the number of students who have joined here, both the clubs. So X is here. That means number of students have joined both the clubs. So therefore, the answer to the question is 15. Because we asked how many students have joined both the clubs and this is X and the value for X is 15. Similarly, now we are asked how many have joined only one of the two clubs. Now, our current diagram can be framed in the following way. We can place the diagram as follows. We have earlier it was X, now we know this X is 15. Now this was 35 minus X, now 35 minus 15 is 20. Similarly, we know that this is 40 minus X, now 40 minus 15 is 25. So now what we are asked is in the part B is how many students have joined only one of these two clubs. That means we have to add this 20. We cannot add this 15 because 15 are there in both the clubs. So therefore we have to add 25 because they are only in the poetry club. So the total is nothing but 20 plus 25, which is 45. This solves the problem. So therefore, we were asked about the number of students who have joined both the clubs, and we also asked about number of students who have joined only one of these clubs, and both these answers we have obtained. We solved the third part. To solve this third part, we need some idea of derivatives, and the derivative we need is derivative of x raised to n is equal to, the answer is n x raised to n minus 1. This answer we need. Suppose we are finding derivative of x raised to say 7. This answer will be 7 x raised to 7 minus 1, which is 7 x raised to 6. So this is something which we need to know. So this is one idea which we need to solve this problem. Now we come back to solving this problem. Show that x is equal to 2 is the stationary point of the function f of x is equal to x cube minus 12x plus 3. Determine whether f of x attains a local maximum or a local minimum. Solution is pretty simple. You have to take f, which is equal to x cube minus 12x plus 3. Right now we are solving only the first part. So that x is equal to 2 is a stationary point of the function f of x is equal to x cube minus 12x plus 3. We find this derivative df by dx. This derivative will be, it is derivative of x cube minus 12x plus 3. Now we have to share the derivative. So it will be d by dx of x cube. Number whenever is there in a derivative, we remove it out. So therefore d by dx of dx, and any other number d by dx, we keep it 3. Now the answer to this using this idea will be 3x square minus 12. Now we should all know that derivative of dx by dx is equal to, again x can be viewed as x raised to 1, which is 1 into x raised to 1 minus 1, which is 1 into x raised to 0, which is 1 into 1. X raised to 0 is 1. So the answer is derivative of dx by dx is nothing but 1. So therefore we get this as 1. And derivative of a number is nothing but 0. So therefore we are left with 3x square minus 12. Now this is our df by dx. Now to show that x is equal to 0, 2 is a stationary point, what we have to do is we have to put df by dx is equal to 0. And when we put df by dx, the value of this was 3x square minus 12. So 3x square minus 12 is equal to 0. So we get 3x square is equal to 12. X square is equal to 12 upon 3, which is 4. So x square is equal to 4. Therefore x is equal to root of 4, which is x is equal to plus or minus 2. Therefore the answer is either x is equal to 2 or x is equal to minus 2. Since x is equal to 2 is there, we say 2 is a stationary point. So this is how you say a point is a stationary point of a function. You basically find the derivative of this function, and in the next part you take derivative is equal to 0. If in the answer you get the point which is mentioned here, right now the mentioned point was 2, and we clearly see that in the answer this 2 is there. Therefore we can say that 2 is a stationary point. Like this we can also say that minus 2 is a stationary point. So this solves the first part of the problem, in which we show that 2 is equal to a stationary point. So therefore, if we want to show that 2 is a stationary point, what we have to do is basically find the derivative, put its derivative is equal to 0, find the answer. If the required point or the mentioned point is there in the answer, we say that it is the stationary point. Now, further, the question goes as follows. Determine whether f of x attains a local maximum or a local minimum at point x is equal to 2. We attach this part, determine whether f of x is a local maximum or a local minimum at x is equal to 2. So for that what we do is, we find out, we have the function f which was given as x cube minus 12x plus 3, and by now we have already found the derivative which is nothing but df by dx to be equal to 3x square minus 12. So what we do is, now we find out the second derivative. To tackle this part about local maxima, local minima, we find out the second derivative, d2f by dx square. And this is nothing but the derivative of the first answer that we have obtained. This derivative, if you observe, is nothing but derivative of x square minus derivative of 12. Now, if you clearly observe, I have removed this 3 out because 3 was a number that was there. So now this will be 2x minus 0. This will be equal to 6x. Now, so we get the second derivative answer 6x. Now, what we have to do to find out it is local maxima or a local minima is, we have to insert this point x is equal to 2 in this. So we have to put d2f upon dx square at x is equal to 2. So we put 6 into 2, 6 to is 12. And because we get 12 is greater than 0, we say that 2 is local minima. If it was less than 0, we had to say it was maximum. So basically, in order to solve the second part, determine whether f of x attains a local maxima or a local minima, we have to find the second derivative. Insert the point inside. If the answer is greater than 0, it is minima. If it is less than 0, it is maxima. This solves the problem. So overall, if we want to show that x is equal to 2 is a stationary point, what we have to do is basically find the derivative. Put its derivative is equal to 0. If the point is there, it is a stationary point, else it is not. To show that it is local maxima or a minimum, find the second derivative, insert the point. If the answer is greater than 0, it is minima. If the answer is less than 0, it is maxima. We move further. If f of x is equal to x square and g of x is equal to 2x plus 1, then find the 2x plus 5 are two functions. Then find the composition f composite g x. We now solve only this part. The derivative part will solve later. Now, to find f composite g at x, there was a formula which was nothing but f of g of x. Therefore, if I want to find f composite g at x, it is nothing but f of g of x. But g of x in our case is nothing but 2x plus 5. Now, but f of x is given as x square. That means if I want to know f of 2x plus 5, if you carefully observe, instead of x, there is 2x plus 5. So the answer will again be 2x plus 5 and this square will remain. So therefore, f of 2x plus 5 will be 2x plus 5 the whole square. Now we all know the answer of a plus b the whole square, which is nothing but a square plus 2ab plus b square. In this, a is nothing but 2x, b is nothing but 5. So it is a square plus 2ab plus b square. This is 4x square plus 2 2s are 4, 4 5s are 20x plus 25. So this gives us FOG. So to find FOG, what we did is we used the formula f of g of x. We replaced g of x by whatever was given to us. G of x was 2x plus 5. We replaced it. Now we observe what was f. F of x is nothing but x square. That means it is a machine that whatever you put inside, it will just square it off. So if x is put inside, it gives us x square. So if I put 2x plus 5, it will give me 2x plus 5 square. So therefore, I get 2x plus 5 square and I use the formula a plus b the whole square to get a square plus 2ab plus b square. Now, so therefore now this solves the first part of the problem. To solve the second part, we have to determine the derivative of the composition at x is equal to 5. Now we have to basically find the derivative of this function. Now this is very easy. Now the derivative of 4x square plus 20x plus 25 is pretty easy to find. So if you want to find the derivative of 4x square plus 20x plus 25, it's easy. We remove 4 out, we find derivative of x square with x. We remove 20 out, derivative of x with x, and we keep derivative of x with respect to 25. The answer to this is 2x. The answer to this is 20 into 1, and this is 0. So we get 8x plus 20. So this is the answer, but we have to also find the derivative at x is equal to 5. So what we do is, at x is equal to 5, we just replace x by 5, and we get 8 5 is 40, 40 plus 20 is 60. This solves the problem. So the second part about finding the derivative is a pretty easy task. Only the first part was slightly tricky, and this solves the problem. Now, we move to the next part. The marginal demand is this. Given the demand is P equal to 2 at 50, at P equal to 2 is 50, calculate the demand at P equal to 3. So if we want to go from demand to marginal demand, we use derivative. But whenever we want to go from marginal demand to demand, we use integration. So similarly, now here from marginal demand, we want to find the demand. So that means we use integration. So demand will be integral of 2p minus 3p square dp. Now we use all in this p terms. Usually we solve integration in terms of x, but because p is involved, we now use everything in terms of p. So we share the integral minus. So now we remove 2 out, and we are left with p dp. So 2, this integral will be p square upon 2. This integral will be p cube upon 3 plus c. Now, I've used this idea. Integral of x raised to n dx is nothing but x raised to n plus 1 upon n plus 1 plus c. So I've used the same idea. This was p power 1. So p power 1 will 1 plus 1 became 2. Down there is 2. 2 is on top. So 2 plus 1 became 3. So you cancel, and you're left with p square. Cancel, minus p cube plus c. This is our demand. But we are given that the demand is 2. Demand at p equal to 2 is 50. Now basically this is given to find this value of c. Usually in economics there is nothing called c. So we have to find this value of c. So what we do is, we use this expression d is equal to p square minus p cube plus c. We put d is equal to 50 because we are given demand at p equal to 2 is 50. That means demand is 50 and p is 2. So we will put 50 here. We put p equal to 50 there, and we put 2 square minus 2 cube plus c. So 50, 2 square is 4, 2 cube is 8 plus c. So 50, 4 minus 8 is minus 4 plus c. We take this 4 that side, so 50 plus 4 is equal to c. So 54 is equal to c. Therefore, now our demand function, which was earlier p square minus p cube plus c, when we insert c becomes p square minus p cube plus 54. Now the problem is we have to also calculate the demand at p equal to 3. That means in this problem we have to put p equal to 3. So therefore demand will be 3 square minus 3 cube upon 54. 3 square is 9, 3 cube is 27 plus 54, and this calculation will lead the answer as 36. This solves the problem. Calculate the effective rate of interest on a 2-year deposit at an annual interest rate of 12% compounded quarterly. We use the formula for compound interest. In compound interest, the amount is given by P is equal to 1 plus R by 4 into 100 raised to 4n. Now, the fact we have used the 4 here just to show that it is quarterly. Now, in this case, in the formula, A is the amount that you will receive, P is the principal that you will put, R is the rate, annual rate, in this case the rate which is there, and N is nothing but the number of years. Now, if you look carefully, amount is something which we'll find. The principal is not given. And in such problem in which we have to find the effective interest rate, we take the principal as 100. Whenever we have to find effective interest rate, we take the principal as 100. The rate R is of course given as 12 and N is always given as 2. So therefore A will be 100 multiplied by 1 plus 12 upon 4 into 100. 4 to is 8. So 100 into 1 plus 4 ones are 4 threes are 3 upon 100 raised to 8. This will be 100 into 1 plus 0.03 raised to 8. This will be 100 into 1.03 raised to 8. So what we have to basically do is 1.08, we have to multiply 8 times to get this answer. We get the answer as 1.266. So if we multiply it by 100, we get 126.6. Now, this gives us the amount. If we want to find the effective rate, what we have to do is, the effective rate will be amount minus principal. The amount, if you observe, is 126.6. The principal which we had taken was actually 100. So therefore, the effective rate is nothing but 26.6 and we write it as percent. This solves the problem. So basically, to find effective rate, what we have to do is we have to use the amount formula of compound interest, insert principal as 100 and find the amount. Then if I do amount minus principal, I get the effective rate.